Okay. Now, we talked about some things, and you have that list, and you probably looked at that. I've looked at that list. First time I looked at it, I thought that I don't even know what that's talking about on most of those things. We're going to talk about a few of them, but not all of them. But we're going to look at it, and if we can, we'll get to Mount St. Helen, and that's really got some interesting information there. But recent dating of civilization. Okay, written history is only back to 3500 BC. Modern man supposedly stopped evolving about 100,000 years ago. If modern man stopped evolving, which means the brain capacity and all of that we have today, if they had that 100,000 years ago, why did it take so long for civilization to come up? Okay, we're not smarter than they are. In fact, if probably anything, we deteriorated. We have more genetic problems than they did back when. Okay, but so that is just a consideration, just something to think about. And then population statistics, how long to get the present populated. If you were to take wars and realize that there's been a lot of wars through the years, and if you were to subtract the possibility of the numbers of people that were killed during those wars, if mankind started with 2 people about 6,000 or 8,000 years ago, we would have the population we have now. Okay? It is the population, I mean, think about it. You know, Australia, now, I mean, within probably 50 years, the rabbits were taking over the country. Okay? Now, humans don't multiply that fast. I understand that. But we do multiply, okay? And people grow and get married, and more children and more children and more children. In fact, you know, once in a while you'll hear a story about some family that, you know, like 3 generations got together, and they were like 45 or 75 people in 3 generations, you know? And so they're looking at the population, and they're saying, okay, if we had, and there'll be another thing about population in a little bit that I'll talk about, but population statistics show that we would be overwhelmed right now if we had been multiplying for 100,000 years, okay? Lunar recession. What's that mean to anybody? It means something to me because I read it, okay? And the lunar recession is the moon is going farther from the earth all of the time. By very little, but it is moving away from planet Earth, okay? So, the moon had to start, if we've been around millions of years, there's 2 options. One is the moon started so close to the Earth that the gravity would have overcome centrifugal force, and it would have crashed into the Earth because it has not moved far enough away from the Earth yet. It's not enough time. I mean, in the length of time that they did it, it would have been way out. We would have lost it. The other possibility is that the moon came flying in out of somewhere and got caught by the Earth's gravity, and it started spinning around them. But the problem with that is that most things that get caught like that, elliptical, because it gets caught, it doesn't round out, and they have a nice round, and I know that the moon gets a little closer, not as close, but not nearly as much as it would have been if it was captured. So the moon, you know, and here's let's see, where's my next one? It's mutation load. Okay, now evolution says mutation can give you new, better things. Okay, you start with an amoeba and you end up with humans. So the mutation was a positive growth. And if we get into evolution, we'll talk about this a little bit more, but we've got so much to talk about there if we want to. But one of the things that we've discovered in the last numbers of years is information theory. Okay, before we had computers, we didn't think about information in the same way, because we put information into computers and then they work. Okay, The other stuff in the past, it was mechanical. You know, you put the gears in the right places and it does what you expect the gears to do. And you can't randomly change a gear. A gear just doesn't randomly switch. Okay, but information, you put it in a computer, and one of the rules of computer is, information theory is, changes of information always deteriorates, always. Nobody has ever said, I turned on my computer today and it started doing new stuff that I've never seen it do before, and it is awesome. What usually happens is you turn on your computer and it crashes, and you go, oh, what happened? And then someone comes and looks at it and says, oh yeah, you probably had a electrical spike and it messed up your hard drive, okay? And random changes deteriorates the situation. Random changes in our DNA has never produced in human history, in knowledgeable human history that we have back, that we can, far back as we can go, everything that has been a mutation has been a negative thing. And so then, and that ties in with information theory. But the negative effect of mutation on organisms, not just human beings, but even smaller and smaller and smaller organisms, would have put things in a place so badly right now that we would probably not be existing. Decay and reversals of Earth's magnetic field. Who's ever thought about the Earth's magnetic field? Wow, I think about that 2 or 3 times every day. You know, I wonder what the Earth's magnetic field is going to do next week. You know, but the Earth's magnetic field is deteriorating at a given rate. Okay, it's getting weaker. Now it's going to take a long, long time for it to get too weak, but the Earth's magnetic field is getting weaker. If you go back 100,000, a million years ago, the Earth's magnetic field would have had to have been so strong that no life could have formed. But if the magnetic field is so strong that no life could have formed, then how did life form 100 million years ago? You know, but it would not, strong magnetic fields kill things. It doesn't make them better, okay? So, Earth's magnetic field. I'll show you a graph of this in a minute. Accumulation of salt and sediments in the ocean. Now, we all understand that over geological ages, and however long that is, whether that's 6,000 years or 100,000 years or 10 million years, that the Earth's crust can shift, okay? But it's been a long time since the Earth's crust has shifted very much. But if you were to measure the amount of salt that's in the ocean, the amount of salt that would have been washed out of soil and into the ocean is we have about enough salt in there to be about 6,000 or so years. It is not a long, long time. Could something weird have happened? In any of these things, something weird could have happened. But all of these things are just little things to look at. Erosion of the continents, same kind of thing. You know, this is just the accumulation of sediments is what happens when the continents erode, and they're still here. You know, we still have continents that haven't leveled out and become nothing. And then the slowing down of the Earth's rotation. We are slowing down. Did you know that probably, maybe back the time of creation, we had 360-day years. We have now 365-day years. The Earth's rotation is slowing down a little bit, okay? And that is scientifically a fact. That's scientifically been proven. And if the Earth's rotation is slowing down in a consistent manner, okay, and who knows whether it was consistent, but consistent manner, then back a million years ago, the Earth's planet would have been spinning so fast it would have been throwing stuff off the globe. Okay, it just like, you know, if you human beings were around back then, be careful you don't take a big step, because halfway through the step you might go flying through the sky because it's spinning so fast, okay? Remember, you know, the faster you spin something, the more centrifugal force it pushes, and it literally pushes things away. So again, none of these things by itself, you would go, oh, well, that's got to be right, you know. But if you just think and look at all of these little pieces that are saying that this is not as big as much time, I should say, this is not as much time as they say there has to be, because how many of you seen magicians do things with little magic wands, okay? I mean, you know, they do fun tricks, okay? Well, the magic wand for evolution is time. Okay, that's why sometimes they make it go, oh, well, the universe must be another 30 billion years older, because these things couldn't have happened in only 10 billion years, so it's got to be 30 more billion years. But it's just long enough time, it'll happen. And this is circular reasoning, because they'll say, well, it has to work because we're here. It has to work. Evolution has to be real. We don't know, we don't understand how it happened. We don't know how life came out of nothing, but it has to be real because we're here. That's circular reasoning. You know, we're here because of evolution. Oh, but evolution's, okay, okay, I'm getting confused. Okay, 5 samples of these processes, and I'll look at these. Are these kind of interesting? Galaxies, comets. We already talked about sediments and sea salt, so I won't spend much time on that. And then I talked about, before I mentioned the idea of people. And this is a little bit more interesting. Galaxies wind themselves up too fast. If you remember spiral galaxies, most of the galaxies are spirals, and the outside is moving slower than the inside, and so the inside is winding it up, and so those arms should be squeezing in and pulling themselves in instead of going the other direction, instead of being as spirals. And those spirals, the universe can't have been very many years old for that to happen. Fast rotation in the inside, slow rotation on the outside, and it doesn't stay in a spiral form. Usually it would turn into a disk, or it would pull into itself in the middle. Our own Milky Way galaxy is supposed to be 10 billion years old, and they've revised that now by quite a bit. But actually, it's less than 0.2 billion years old, and it could be a lot younger, but it's less than 2 billion years old, because it would have, the whole shape of the galaxy would have changed, okay? Now, when we mention things like this, where it says less than 0.2 billion years, that's the upper limit that it would be the possibility, using that as a scale to figure out how it could be. But if God created it with the arms in certain position, then then it could be way younger. And God's God. And if I believe this with all my heart. If God wanted to create universe 1 second ago and give us all the memories that we have, he could do it. Okay? We don't, I mean, in all honesty, we don't know that anything is longer than the now that we're in, you know? I don't think he did that, but I think he's capable of doing that. Then lack of population, star supernovas, this is beyond me, but they have scientifically shown that supernovas, certain amount of supernovas happen in the universe over a given period of time, and if it's been 10 billion years, there's not enough supernovas out there. Okay, there should be a lot more than that. No population of type 3 star supernovas, and that's when I start getting lost. I can't even keep up with type 1. The universe consists almost entirely of hydrogen. Stars take hydrogen and turn it into helium, okay? And then the atoms join together under the extreme the gravity pull of the sun, okay, of the stars, and other elements can get formed, okay? And if the universe were 100 or 10 billion years or 30 billion years old, there would be way more hydrogen used up. We've got way too much hydrogen in the universe, and they can see that by our spectral analysis of stars and stuff like that. And that's an interesting one. Galaxies have not torn themselves apart yet. And by the way, are you familiar with the term red light shift? Okay, are you familiar with the Doppler effect? That's a scientific name for that. Doppler effect is, if you're standing, it works for sound and it works for light also. And doesn't make sense to me. But it's a reality. If you're standing still and a freight train's coming down and their horn is going, when they're coming towards you, the sound is a higher pitch. And the pitch gets, as it gets close to you, it's a high pitch. And then as soon as it gets right in front of you, it's exactly the right pitch. And then as it goes farther away, it gets deeper. Okay, a high pitch coming towards you, and the way they describe it is, as it's coming towards you, is pushing the sound waves closer together. Okay, and so you're hearing a higher pitch. When it's past you, then it's stretching the sound waves away from you, and you're hearing a lower pitch. Evolutionists say, and this might be true because God says, the Bible says He stretched the heavens. We talked about that last time. They say if you were at any point in the universe, you would have red light shifts from all around you. Everything is moving away from everything else, fast. Red light shift. It's going away from you. Well, why? If it's going away from one, why isn't it going towards the other one? And you know what? If you took something and you stretched it, it's not getting closer to anything. They're all moving apart from each other. If we had a huge rubber sheet with a lot of polka dots on it, and we all grabbed four corners and we begin to pull it apart, they would all be moving away from each other. It would not be coming closer together. And it literally says that God stretched the universe. He spread the universe out like a cloak. To me, that's just amazing that the Bible literally declares that. And there's another one that comes along later with that kind of a thing. Presence of spiral arms of the galaxy, we already talked about that. Short orbit comets. A comet typically loses 5 to 10% of its substance as it goes around the sun. How many hundreds of years? Now, some of them don't show up, maybe once every 70 years or maybe once every 500 years. But if you've got 30 billion years, that's a lot of trips around the sun that is still coming. And so short orbit comets. Now, the ones that are huge, long orbits, then that's a different kind of a thing because they just don't get around the sun very often. But any short orbit comets, they declare that that is not that long a time. Now, this is something that I don't understand. The thorium, I can't even pronounce the second word. The ratio between the youngest and older stars, there's not much variation. The older a star gets, the less of the first that they have, and the more of the second. When they are young, when they're really young, they have a lot of the thorium, and they hardly have any of the other, and the ratios aren't right for old stars. Presence of the fragile ring structure of Saturn. The rings that go around Saturn, they should have been shattered by now if this is billions of years of evolution. This shows you a picture of the comet, and comets they fall apart too soon, and it's like okay. Solar system's young, supposed to be 5 billion years old. Actually, many evidences show that it's 10,000 years old or younger. Here's the picture of the graph of the sediments coming in and stuff like that. Don't want to do too much of that because we already talked about it a little bit. Seafloor sediments are young. Yes, we talked about that. Here's the salt, another graph. I didn't know I had two graphs like that. The sea is young, supposed to be 3 billion years old. It's actually less than 62 million years old. And again, the significance of that isn't that it's more than 10,000. The significance of that is that in 62 million years, evolutionists would tell you that there's no possible way that life could have formed. Okay, so if the planet isn't as old as they think it is, they just all agree it couldn't happen. And here's talking about people again. Too many Stone Age people would have lived and died if we have been around for 100,000 years as human beings. Okay. An average, one generation is the average time to grow and have children. A generation is about 25 years. And in Bible times, a generation could be 1,000 years, could be 100 years. They would talk about a generation of being 100 years. But a generation, we're not talking about Bible generations. And I think another generation in the Bible is 40, because this generation passed away and they were in the wilderness 40 years. But anyway, 40 years, but 25 years we consider to be a generation. And so in 100,000 years, as far as a human being and being able to reproduce, etc., we would have 4,000 generations, okay? Now, the number of people that would have died in 4,000 generations, okay? The number of people that would have died in 4,000 generations would be billions of Stone Age graves, okay? We would run out of space to bury them all. Now, did they burn them all? Did everybody that died get cremated? Well, that would be one way to get rid of them and not fill up the earth. But in 4 billion, in 100 million years of Stone Age life, we would have had 4 billion bodies to bury. We should be finding huge numbers of skeletons out there, and we don't. Thousands have been found, but not billions. And then Stone Age, we think it's supposed to be 100 years long. The Stone Age and all the stuff that was supposed to happen during that time could have taken place in less than 500 years, okay? And if the time that we talk about as Stone Age people, then that situation, if it only was 500 years long, and you know what? We've only been in America 250 years. 500 years is a long time, you know, especially when your lifespan is maybe only, it was longer back when, but maybe only 50 or 60 years. So galaxies, comets, sediments, sea salt, and people are more things that show that the earth is young and heaven is young and mankind is young. Okay, now, creation scientists are working on explanations for the old data, because there are some things that are old data. It seems like the earth is really, really old. Carbon-14 dating. We say that, you know, they find things that are 25,000 years old by carbon dating. Radiologic dating with this potassium argon thing, and seeing galaxies billions of light years away. How can we see, if the earth has only been around maybe 6,000 years, how can we see light that is 1 billion light years away? Okay, how can we do that? We'll talk about that in a minute, okay? Carbon-14 dating, now, there's evidence that there was 16 times more carbon dioxide in deep strata minerals than back in the time that would have been the flood, that would skew the data totally wrong, and that it wouldn't be like it is today. And any of these things can be looked at in different ways. Radiological dating is people that have searched this stuff out, and it's not me, okay? If you look at the white box, there's not enough helium in the air to be very long a time. There's too much helium still in rocks. There's not enough lead diffusion and not enough argon diffusion. I don't even know what those radio halos, I think I kind of know what they are, but we'll see if we get to those, okay? So it's very, very, very possible that what the geologists and evolutionists talk about as millions and millions and millions of years do not have to be millions of years of time. And this is one that's very interesting, okay? I'm not sure I understand this completely, but I think I do enough to get confused together with you. Remember, the Bible says God stretched out the heavens. Okay, if God literally stretched out the heavens, okay, if God literally stretched out the heavens, then we should, as the stars were being stretched out, we would have a redshift, okay, because they're going away from us, okay, and believe it or not, if you're on planet Earth and they check the stars all around us are redshift. We're not moving through the system, and one side is a redshift and the other side is blue shift. It's all redshift, okay? But if God stretched that out, then, and redshift is kind of like you're stretching, and I don't understand this, but you're like stretching on the sound. You're stretching the space between the sound waves, and so it sounds deeper. Because remember when you pluck a bass guitar, The strings go, okay? And you pluck a banjo and it's, okay? Because it's vibrating a lot faster and a lot slower, okay? So when they stretch it out, okay, the sound changes. Well, when they stretch out light, when light's moving away, and light's light, I don't understand it, but it's scientifically been proven. When light's moving away, the source of the light is moving away, it's like you're stretching the space between the light particles or something. Remember, okay, this is also confusing to me, but light acts like a particle sometimes, and it acts like a wave sometimes, okay? How can it be a particle and a wave both? Ask God. I don't know. Okay, but if you're moving away, okay, then it's got that redshift, and so you're leaving light behind you is what's happening. So God's stretching that, and if He stretched the universe, all of a sudden it's like you've got, okay, I'm right here. Today those stars were here, and I could see the light, and they were all close together, and tomorrow. Those got stretched out, and now those lights are 100 billion light years away, but as they got stretched out, they left light behind them. Okay, that's one theory. The other theory is this one. This one's really interesting. Okay, we know from good old Einstein that theory of relativity, and this has been proven. Clocks go slower when they're moving faster. Okay. Clocks move slower when they're moving faster. So the closer you get to the speed of light, that's why they think the speed of light, you can't get past it. But when the closer you get to the speed of light, the slower time goes. Okay? And they also have proven that the more gravity that there is, okay, the slower time goes. And I'm not sure how those work together, but that's just the two pieces. Okay, you got a clock in a hole in the ground, very far, and you got a clock on the highest mountain, and they do not keep time. They're not synchronized. Now they don't lose much time, but the difference between gravity there and the gravity there is not very much. But if you had the Earth, if you had creation and all of that gravity was there, okay, and you're in the well of the gravity on planet Earth, and then those things begin to get stretched out, then that gravity changes, and there are some very brilliant scientists that are creation believers that have come up with a theory that is hard. I don't understand it, but they have presented it, and the people who are way smarter than I am searching it have not found problems with it. It's not a proof, but it's a concept that when on the fourth day, when God stretched the heavens, okay, that the time on those stars that were farther away moved way faster because it got farther and farther away from the center of all of the gravity, and the time on planet Earth went slower. So in one day, these things could get 100 billion light years away. Okay, how fast did God stretch it? I don't know, but I think He can stretch it pretty fast. So if that confused you, that's okay. I'm not sure I completely understand it either. It's just interesting that they have been able to look at that. Okay, we don't, yeah. Okay, I think this is light created in transit, and then the speed of light. Another concept is that has the speed of light change speed? Is the speed of light different than it was back at the beginning of creation? And those are just wild guesses. They cannot prove either one of those. But with the idea of the clock slower at the center of the universe and being stretched out, that's the one that a lot of the creation scientists are looking at and considering that that's at least a possibility. Okay, so the creation theories, they start with the assumption that God created heaven and earth. The Big Bang theory starts with the assumption that there is no God, and so it had to come out of someplace. Okay, and string theory is the closest thing that I have ever heard and I like science, and I don't just dig into it constantly. But string theory is a fairly new theory, and it says essentially that everything is created from vibrations. Okay, that there is I think enough to know that there's more empty space in you than there is substance. That if they were to take all the space out of the atoms and all the space between the atoms, and they would take it and compact it down, your whole body would probably fit on the head of a pin. Okay, your body it is the forces that create who we are, that the way they interact and work with one another. And so the idea of string theory is that there's just vibrations. Now, how do you have vibrations without atmosphere? I don't know, but vibrations. And when I first heard that, I thought, well, maybe that's how it works, because it says God spoke. And when you speak, what creates the words? Vibrations. That's what creates the words. So I just like, okay. And again, I need to point out, if I didn't do this before, science that we know today, not science from 500 years ago or 1,000 years ago, but science today starts with the concept that if you can't see it, feel it, touch it, taste it, repeat it, it isn't real. Okay? So they completely leave out anything that's what we would call supernatural. They don't even consider the possibility that there is an outside creative force, because we can't see it. You can't prove God. Well, I think it would be difficult to prove God to a skeptic, but it might not be difficult to prove God to someone that comes to know Jesus Christ as their Savior, because we've seen the impact. It's like the wind, air. You can't see it, it's just there. I mean, you look right through it. What's there? But you can feel the effect of the wind. And sometimes you can't, you don't see God, but you can feel the effect of His presence. Okay, so that's essentially where I am. Okay, this part is not, this is just a kind of repeat of what we're already looking at, and the slow and fast time. Okay, in the past the cosmos was smaller, and even Big Bang Theory agrees with that. And the scripture we read quite a while at the very beginning of the topic last week, talking about God who stretches out the heaven like a curtain and spreads them out like a tent to dwell in. And then, during the 6 days on earth, billions of years could have elapsed in the distant sky, using the idea that of either stretching or of the times being different. Okay, then we come to this. Okay, and we're going to talk about Mount St. Helens for a little bit, and to me, this is really, really interesting from a variety of ways. I mentioned it last time, and my wife made a nice surprise for you when I pulled that off. This guy here is a remnant of Mount St. Helens. If you recognize obsidian, a normal, this is glass made in a volcano. Now, most glass made in volcanoes comes out black. And obsidians, the Indians used to make arrowheads out of them because it could make really sharp edges. But this happens to be the contaminating chemicals in this happened to be what turned it green. But this came out of a volcano, came out of Mount St. Helens. And my wife reminded me of something, and I've got to figure it out. And because I said my boss had been in the Mount St. Helens volcano eruption, but Mount St. Helens didn't erupt till in the 80s, and I worked with him in the 70s. So I got to figure out what eruption was he talking about, because he literally described to me what had happened when he was at a place that there was a volcano eruption, but it couldn't have been Mount St. Helens. So my wife graciously, not in front of everybody, corrected me so that I can fix it today. So Mount St. Helens shows us changes we used to think took millions of years can happen in decades, okay? And this is some interesting stuff. Mount St. Helens and the age of the earth. With Mount St. Helens, canyons formed almost instantly in like 3 days or a week, and we'll look at some pictures. Thick layers of sediment were deposited quickly, and some of these layers, you know, when it says layers, it wasn't all uniform. And you know, one of the things they look at the sides of canyons, and you see all these layers that are there, and the typical geologist says, okay, well, this layer probably took about 10 million years for this layer to form, and then this layer forming right above it, this probably took another 8 million years. And it's almost like rings of a tree. They say, well, this one probably took this long, this one took this long, and that kind of thing. They look at the layers and feel like that they literally took a long time to get the layers. And that's one of the things with Mount St. Helens, absolutely destroyed that theory. Forests and polystrate trees, that's the ones that the tree goes up and down, through different sedimentary levels were formed quickly, okay? We'll look at some pictures again in that. And then coal formation. Typically, scientists will tell you that coal takes millions of years to form, okay? And that's just the fact, okay? And we're going to see some interesting things with Mount St. Helens. Okay, Mount St. Helens in the pre-eruption was just a nice mountain. It was a beautiful lake, and you know, people went there for vacations and had a great time. And then, boom, the volcano went up. Okay, the eruption force was equal to 30,000 atomic bombs. Okay, this is not a small thing. Okay, one of the volcanoes that went up, I think it was. I can't even tell you. If I were to guess, I would guess wrong. But it blew up, and so much dust particles got into the air that for at least 1 year they did not have a summer. Okay, it stayed cold because the cloud cover. It wasn't even just clouds. It was literally dust in the atmosphere that covered the whole Earth. I don't know if it lasted more than 1 year, but it lasted at least a year. And crops wouldn't grow. I mean, it was horrible. It was just, but that's how big a deal that a volcano can do. This one was basically a small volcano. It wasn't the big one. I mean, it did a lot of damage, and changed a lot of things. One side of the mountain was totally blown away when the eruption hit and it blew up. You know, it's almost like here's the mountain, and this side was devastated, destroyed. Now, a plastic cloud of hot air, steam, and dust rushed over the surrounding area. And that just means that that's a cloud that was changing and lots of different kind of stuff in it and just rolling and boiling as it came out. And that cloud and the lava coming out was shaping and scouring. Now this is I don't know if this is early, or I think it's probably later, because you see that where it looks like half the mountain at the top was blown off. So this is a little bit later, and it was you can see where the smoke, the lava and the smoke cloud was still coming out. It had not calmed back down all of the way. Here is, if you can see that looks like almost cotton batting at the top. That is lava flow. That lava flow came rolling out, and in some lava, that's one of the cloud things that it talks about. Some lava is just smooth and just comes out, but some of it is just like a. If someone blew a dam, and the water coming out of that would not flow smoothly at first, it would just roll and rumble coming out, and that would be what this is a picture of. And that, if you see the little, yeah, you can see it pretty good. Here's somebody's camping trailer. And this is that rolling cloud coming over it. Now, obviously, that guy was gone by then, but close enough to get a picture of it, and that would be scary. If that were rolling my way, I don't think I'd take a picture. I think I'd get away as fast as I can, because that is extremely high heat, and it is moving. One place I read that there were times that this is moving at 60 miles an hour. Okay, you're not going to outrun that thing. I mean, you might get in the car and beat it, and this is the lava flow that you normally think of as lava as it came out at night, and you could see it was just a flow that was coming out. But this is a different stage of when the thing blows up. The first part was the clouds and that cloud. I can't even remember how to say that word. This is a little bit more. This is fuzzy. You can't see it as well. But it's like that first cloud. That this is just it coming down. Right here on the sides, you can see trees. Okay, so this is on the ground. This is not flying in the air. This is literally rolling down the ground. But it's not as heavy as normal lava would be. It's got a lot of air in it, and it's got a lot of movement in it as it's coming out. It would be like a really, really, really thick fog, really thick. Okay, this is a picture of one of the areas where the lava flow went through, and somebody just happened to spot that, and I thought, oh well, that's an interesting picture. The lava, and this back here, this might not all be lava, because it looks like a lot of this might be dust that settled down. And that's one of the things that when my former boss was talking to me about where he had been, that the dust was so thick that it burnt cars up. It got in. They used carbureted cars back then. I don't know if they would be a lot better now, but it got through the carburetor, got into the block, and it just turned the oil in there into thick mush. While he was driving, while he was still able to move, it was scouring the front of it just like sandblasted his front end of his car. It just took all the paint off of it. Okay, now this is a canyon formed by Mount St. Helens eruption. Pretty impressive. Okay, that was formed in 3 or 4 days. Evolutionists, 100 years from now, if they didn't know that thing blew up, they would look at that and they would say, wow, I wonder how many millions of years it took for that to happen. And it didn't take millions of years. Now notice what the structure looks like. Okay, this happened not within days of the eruption, but it happened when there was a bottleneck that happened, and that bottleneck broke open. And it was not lava at that time. It was almost like a thick scouring water kind of a thing. And as it went down, it did this. Okay, and they have before and after pictures, but I don't have them. Now look there's the Grand Canyon. Now this canyon is maybe 1/40th the size of the Grand Canyon. It's tiny. It's small. Okay. But if you look at this, and if you've ever been to the Grand Canyon, I wouldn't be able to tell you which canyon that came from. And here's the picture of the Grand Canyon, a lot of the same colors, but you can see the layers and how it is layered around there. And what scientists want to tell you is that these layers, it took millions of years for these layers to get filled up, and it took millions of years for it to grind down and create this valley with a little stream down on the bottom. But it wasn't eroded by the little stream. It was eroded by this huge volume of water that came busting out. Now, think about Noah's flood. It would be easy to surmise that as the water was receding, okay, the water was receding, that there were some places where there was a lot of volume of water that all of a sudden got unbottlenecked. And that water was able to rush through that area and wear it down, scour it down like this one did. But this happened again not many years ago, and here's those tree trunks like we showed a picture of last time, where the tree was just standing up, and evolutionists not quite sure what to do with that, because they've come up with different theories, but they're not quite sure what to do, because as the bottom would be petrified, this part should have rotted away if it took millions of years for the sediment to build up. Okay, so we can wear it away a lot faster than they expected, and then we can build it up a lot faster. Now, Spirit Lake is right close to Mount St. Helens, and it was a lake there before Mount St. Helens blew up, and it's just it was a recreation lake. Nobody does anything there now, but it was a recreation lake, and this here is a mat of dead trees. When the volcano blew up and all the wind and all of that stuff happened, it knocked those trees down, and they ended up down in that lake. Not all of them, because some of them went different directions, but a huge amount of them ended up in that lake. And somebody drew some pictures of what was happening there. They had scuba divers that went down, and were looking at it after all the stuff had settled down and when it seemed to be doing okay. And there was some of the logs were still floating. Some of the logs were floating straight up and down, and most of them, they didn't show that here, but most of the ones that float up and down, they have a big root ball on the bottom that makes it like a ballast and holds them down. Okay. And then here it shows one that has come down and touched the bottom. Some of them are laying down sideways. They just floated down differently. And then this is basically the same as this, just in a different position. And they have found these in what used to be ocean beds or lake beds and stuff like that as they dig down and they find petrified wood. And they have always thought that, that those were trees that had grown there, but these were not trees. They were deposited there from a different spot, okay? And the upright floating, and they were buried into the silt as it begins to go, and then that silt went fast, okay? And I might have it in my notes, but there's just so much about this stuff, and I didn't want to wear you out too much, but yeah. Up to 400 feet of strata have formed since 1980, when it's up to 400 feet. Well, if 400 feet is like this, then it doesn't take a million years to get a layer of strata. It doesn't take that long, okay? Because and they have wrapped up and wrapped around that, and there's this is not Christian Science. This is science. That model for the origin of coal, and what they have proposed is all of these logs here. These are logs that have been brought into a body of water by some means, whether it was a hurricane came through, or whether it was like this one was a volcano blowing up, and then over time, the wind blowing and the waves moving and stuff, it knocks all of the bark off the outer part of the tree. Okay, it's just stripped off. And it goes down into the bottom of that ocean or sea or lake, and peat moss forms. And it's like millions of years for this all to happen. Except this log mass has already developed, I think, a 3-foot layer of peat moss in the bottom of that lake. And the peat moss is already beginning to take on some of the aspects of coal. It is not coal. But they think that it takes pressure, because if you had if all of a sudden you had a whole bunch of water get on top of something, there's a lot of pressure there. Okay, they think it takes pressure and heat and time to make coal, and that's a very good possibility. But I think that the time length that they think it took to make coal is way, way shorter than what they believe. So the log met in Spirit Lake at Mount St. Helens has already, all of the outer barks have been stripped off, and it has made a layer of peat moss that you could harvest that peat moss and sell it for peat moss. It's already there. It didn't take 1,000 years or 10,000 years for that to happen. Okay, that brings that to an end. Now, next week, I am going to be showing a video, and so on the streaming. I won't be able to do that on the live streaming. It will not happen. I want to look. It has information about Mount St. Helens. If it doesn't have something that's a lot more than this, I won't bore you by doing it again. But then I have one that is called This Privileged Planet. And it was produced in a very nice way. A lot of really phenomenal information about how special our creation is. Okay? It seems to be finely tuned for human beings. And it seems to be finely tuned for human beings to be curious and to discover things. I'm not going to take any more time. We're just about out. But I just want to, if you've seen this Privileged Planet movie already, then you can come and enjoy it again. But if you haven't, I think you will really appreciate it. I'm not sure how long it is. I just got it in the mail today, so I haven't even taken it out of its package. And I don't know if it's more than an hour. Hopefully it'll be like a 1 hour segment. And if it's more than that, I'll go through it and see if there's places that we can jump and squeeze it into an hour. But anyway, I think that you will really, you realize that the universe is so finely tuned that it took a creator. Okay? I remember, I don't know if this is a true story, but this is an interesting, at least allegory. A man walked into a friend's house this is back in the probably 1700s. It's supposed to have taken place. And someone was an astronomer and had made a beautiful scale model of our solar system. And it might not have been as perfect as we would know with our information today, but it had been designed, and if you used the crank, the stuff would rotate and move. Okay, and so the moon went around the Earth, and the Earth was going around the sun and all of the others, and it was all moving, and the guy walks in, and the visitor walks in and says, "Wow, that is awesome. Who made it?" And his friend knew that this guy was not a believer in creation, and so his friend said, "Oh, nobody made it. It just popped up. There it just, wow, there it is. It just appeared." And the guy said, "Oh, come on, it's obvious. There's no way possible that this could just pop in and be that. And, you're giving me a hard time here, guy. Just knock it off." And the guy there, the one it was his home, he kept just insisting, no. And the guy finally came to the conclusion that what you're trying to get me to understand is, if this, as simple as it is, would need a creator, how much more would this complex as our universe is? The odds are higher that you could take a bunch of junk in a junkyard, and a hurricane and a tornado could come through, and when the tornado was gone, you would have a Boeing 747 ready to fly with fuel in it. Okay? The odds are higher for that to happen than for the universe to have happened on its own. We would realize that the first is impossible. Our watches nowadays, most of the time, are, little battery inside running a little computer chip of some kind. But back when they made watches in I remember those really nice watch because those 17 jewels were part of they were the bearings that they turned on, so they were really, really nice watch. Well, you open up one of those things and dump the stuff, and try to put it back together. Not unless you are a master watchmaker. You would never be able to put it back together, much less create itself. And then the one I like the best is scientists have never been able to recreate life at all. And you can take a test tube with all of the right ingredients, and you got some amoebas, okay? And if you've ever seen pictures of amoebas, they're just a single cell animal that kind of somehow moves around, and it can eat food and doesn't have a mouth, but it can still kind of get food inside somehow, and it's alive. It's doing that. Okay, so there's a live thing. All the foods there that they need, but you poke that little amoeba with something to break the cell membrane. It's dead. All the ingredients are there, but it's dead. And you can store those ingredients, and you can hit them with electricity, like lightning, supposedly. You can do. It was a living thing. All of the components to make that thing alive, they cannot bring life back to it. A whole lot of reasons that I believe in a creator. Probably know him as my personal savior, and that is a biggie. So anyway, thank you for the opportunity to look at these aspects. Maybe this, maybe that, but what we know for sure is that the scientists are still guessing. They're making wild guesses, and they're leaving out a major component of that which is unseen by us. Just because we can't see it doesn't mean it doesn't exist. And Father, we are grateful that you created heaven and earth, and you created us to be your children and to enjoy your creation. And Father, we pray that you'll keep our hearts encouraged and stirred in you, and let your blessings be upon each one. And let this be a wonderful rest of the week, and come to joint service on Sunday, just expecting your presence in a very real, very special way. God, the very reality that you visit your children is awesome, and we thank you. And we just ask your blessing again in Jesus' name. Amen. Amen. I forgot to ask if you had any questions or observations. My wife says I go fast sometimes, and I do. This is fun to me. This is really interesting to me. So I hope that you have enjoyed it. I think the movie will probably be a little slower paced than what I am doing, because they're professional in what they do. If I were teaching algebra, I would slow down, because I know I can't go that fast with algebra. You gotta get it through and give two examples, and if that doesn't seem to make sense, give them another one. And it's kind of hard to do that here, but we're trying to help you understand that what appears to be common knowledge out there about the age of the universe and all that kind of stuff is not common knowledge. There's a whole lot of people who are very, very experienced and educated scientists who have 100% different opinion upon things like this. And like I said about the wild and woolly imaginations of people with aliens, if I'm wrong in half my suppositions or all of them, that isn't going to change my opinion of God, it is. God's awesome. He's created heaven and earth and created us to enjoy it. So bless you. You want to come look at? We were told, Larry, you can go ahead and turn this off if you haven't already. My wife's cousins thought this was an emerald.